Earth feels solid and motionless beneath our feet. We walk, build cities, and observe calm oceans, all with the impression that the planet is at rest. But this perception is an illusion created by motion that is constant and uniform. In reality, Earth rotates once every 24 hours. At the equator, this rotation corresponds to a linear speed of about 1,037 miles per hour. Even far from the equator, the surface of the planet is still moving at hundreds of kilometers per hour. We do not feel this motion because everything around us, the ground, the oceans, and the atmosphere, here, is rotating together as a single system. Now, imagine a hypothetical scenario. What would happen if Earth suddenly stopped rotating for just 1 minute? This is not something that can happen naturally, but it allows us to understand how deeply rotation is embedded in our daily reality. If the planet stopped instantly, the ground would stop moving, but everything on its surface would not. Due to inertia, objects, oceans, and the atmosphere would continue moving eastward at the same speed they had just before the stop. This is a fundamental law of physics. An object in motion tends to remain in motion unless acted upon by an external force. The atmosphere is not rigidly attached to the planet. If Earth stopped suddenly, the air would continue moving at the rotational speed. At the equator, this means winds of over 1,037 miles per hour, faster than any hurricane ever recorded. Even away from the equator, winds would still be extremely strong, capable of moving clouds, dust, and debris across continents. These winds would not appear as sudden gusts, but the force acting over landscapes, forests, and cities would be immense, showing how dependent our environment is on Earth's steady rotation. The oceans, like the atmosphere, would continue moving due to inertia. Water masses at the equator would surge forward at speeds over 1,037 miles per hour, carrying immense energy. Even in mid-latitudes, the displacement of water would be enormous, creating waves that could travel across entire ocean ba. Since coastal areas would experience sudden flow, while inland rivers and lakes could also surge temporarily, the magnitude of water movement would not be uniform, showing clearly how much the oceans depend on the steady rotation of our planet. Buildings, bridges, and other structures are designed to withstand gravity, but not sudden horizontal forces of hundreds of miles per hour. If Earth stopped rotating suddenly, the ground beneath these structures would while everything on top would continue moving. Even large, heavy objects could be displaced, causing structural damage and collapsing weaker constructions. Roads, bridges, and vehicles would be subjected to extreme horizontal forces, showing how much modern infrastructure relies on the stability of our planet's rotation. The Earth's crust would stop first, but the mantle and core would continue rotating due to inertia. This difference in motion would generate internal stress along fault lines and tectonic boundaries. As a result, earthquakes could occur in regions not normally prone to them, and volcanic activity might increase temporarily as magma moves under new stress patterns. These effects would not create instant global destruction, but they illustrate how the planet's rotation contributes to the balance of geological forces. Earth's rotation is not a background detail. It is a fundamental condition for stability, climate, and life. Stopping it would require more energy than the entire planet could ever encounter. The motion has persisted for billions of years, stable and predictable. What feels still and calm beneath our feet is actually motion in perfect balance. Our world's stability depends on this continuous spin. Thank you for watching this exploration of our planet. Next time you look at the sky or feel the wind, remember the delicate balance that keeps our world spinning. Stay curious and keep exploring the wonders of science.